Look up at night, and the cosmos appears perfectly calm. Even our close neighbors, orbiting in steady, predictable rings, project a sense of quiet, clockwork precision. We build massive, gold-plated mirrors to capture faint infrared light, allowing us to push past that local stillness and peer nearly 13 billion years into ancient space. But the further out we look, the more that tranquil tapestry breaks down. Deep space is an active, highly volatile environment. Those points of light aren't permanent fixtures. Every single star is essentially a massive pressurized reactor slowly running out of fuel, inevitably building towards its own structural collapse. To understand the actual mechanics of the universe, we have to ignore the serene glow and study the physics of how these colossal objects tear themselves apart. The death sequence begins when a star exhausts its hydrogen. It swells into a red supergiant. As its outer layers expand, it turns its heat back on the solar system, boiling off oceans and cracking the crust of close-orbiting planets. Friction from the star's expanding atmosphere drags those planets inward. The rock liquefies entirely before spiraling down and vanishing into the stellar fire. Eventually, the swollen star hits a physical limit. Without enough internal outward pressure, gravity takes over. Trillions of tons of gas collapse inward at a fraction of the speed of light. That falling material slams into the dense iron core and rebounds. The resulting supernova shockwave blasts stellar debris outward with enough kinetic force to shred any surviving planets in its path. For a brief window of time, that single explosion emits more light than the billions of other stars in its home galaxy combined. The supernova strips away the outer atmosphere, exposing a highly compressed, incredibly dense core and vacuum. When the blinding light fades, a crushed stellar corpse remains. If the core was massive enough, protons and electrons are crushed to form a neutron star, packing the mass of our sun into a sphere the size of a city. Conservation of momentum forces it to spin hundreds of times every second, generating violent magnetic storms that sweep giant beams of radiation across the galaxy. If the star is even larger, the core collapses entirely and rips a hole in space-time, leaving a supermassive black hole. This diagram illustrates how a black hole feeds. Its extreme gravity drags surrounding gas, dust, and shattered stars into a tight orbit. As material accelerates near light speed, friction creates a blazing accretion disk. Notice the curved paths here. Intense gravitational pull warps photon trajectories. Light rays from behind are dragged into curved arcs over the pitch-black center. When supermassive black holes feed aggressively, they ignite into quasars. The sheer volume of infalling matter triggers massive jets of radiation that blast outward, consuming entire stars and dominating their galactic neighborhoods. Any gas, light, or debris slipping past the event horizon is severed from the observable universe entirely. It is a permanent point of no return. We can observe this kinetic chaos operating on an even larger scale. Over billions of years, entire spiral galaxies drift into each other's paths and crash. Gravity pulls their glowing cores together, scattering millions of individual stars outward into deep space. These immense galactic mergers, combined with feeding black holes and supernoval blast waves, churn the interstellar environment. They throw newly forged heavy elements across huge distances. This widespread obliteration acts as the universe's recycling mechanism. Without it, the cosmos would simply run out of building materials. The scattered debris fields left behind by exploding stars eventually cool off. Over millions of years, they clump together into dense, towering columns of gas and cosmic dust floating in the vacuum. Deep inside those clouds, gravity goes to work on the recycled elements. It slowly compresses pockets of gas tighter and tighter until the friction becomes too immense and a brand new star ignites inside the nebula. The carbon in the Earth's crust and the iron in our blood were violently forged in the death throes of ancient stars. The universe requires this continuous cycle of destruction to build anything new.